In this brief video, we'll go over some terms that can make or break a research method student and can even cause some of the most seasoned researchers some headache. First, let's talk about levels of measure. There are two primary categories of data. Continuous data are numbers that range from negative to positive and hold meaning as the number that they are. For example, if we are discussing numbers of arrests in a given month in a specific location, the numbers of arrests are measures of the number of times a police officer detained someone for committing a law violation. Categorical data are exactly what they sound like. They're categories of something that we use to describe some phenomenon or concept. For example, as criminology and criminal justice students, we know that the FBI categorizes crimes into Part 1 and Part 2 crimes. Part 1 crimes are the street crimes we're most familiar with, like violent crimes or property crimes. Within each type, violent or property, there are categories like homicide, robbery, burglary, assaults. If we want to effectively and efficiently aggregate types of crime, we can assign a number to each category that will work nicely in a database or spreadsheet. The different levels of measure used for data allow us to best determine how to describe and analyze the data that we are working with. Nominal level data are categorical data for which a number is used as a placeholder of sorts. The number itself doesn't mean anything really, it just represents a specific category. Think of the different racial categories that are often used in social science research. I might use a number 1 to represent the race category white, the number 2 to represent the race category black, 3 for Asian, etc. The numbers I choose don't put races in any type of rank order. I can't add the numbers to create new race categories, but I can add up all the number 1s in a data set and determine the number of individuals who self-identified as white in my sample. Ordinal level data are categorical data, and the number or numbers used to represent the concepts do have a logical order or meaning. For example, I might be interested in better understanding the data that I am working with through the lens of age. Maybe I've asked for people's experiences or opinions, and I think that age influences their response. I may use 1 to represent people in my sample who are 10 to 15 years of age, and 2 to represent people in my sample who are 16 years of age and older. In this case, the lower number that I assigned, the number 1, means younger than the higher number that I assigned, the number 2. Interval level data are numerical, and the number 0 is arbitrary. It doesn't mean that something doesn't exist, but it isn't necessarily meaningful. Think of the concept of height. Someone can be 48 inches tall. I suppose we could have someone who is 0 inches tall, but we won't see this often, if ever, so our measurement of height rarely, if ever, starts at 0. The 0 just doesn't mean something here. With ratio level data, 0 can mean the absence of something. Often, zeros are used with dichotomous measures. You may hear the term dummy coding, and this generally means that 0 is the absence of the thing we're interested in. In other words, if I were entering sex, male or female, then male could equal 1 and not male equals 0. It's like 0 is no to the question, does this case have X? Check 1 if yes, and 0 if no. All of the levels of measure are key to our ability to decide how to analyze our data. We also need to keep in mind the unit of analysis. Our data's units of analysis might be very large in scale, like countries. This is an example of a macro unit of analysis. We could also have a micro unit of analysis and be interested in the characteristics, experiences, and opinions of individuals. The variables we choose are pretty abstract concepts that we define. Often, we define our variables based upon the lion's share of theoretical and empirical works that have guided our own work. For example, if I'm interested in the variable property crime, I might define this variable as a law violation involving the damage, destruction, or unlawful taking of someone else's owned property. If my unit of analysis is macro, say states, I'd be measuring the variable property crime by aggregating all arrests or victimizations of a property crime that is known to the police within each state. If my unit of analysis is micro, I might ask an individual how many times they've been the victim of a property crime. Measures are ultimately how we define our variables, and it's important that we are using the proper level of measure for our unit of analysis. So think about a data spreadsheet. Most of us have all seen an Excel spreadsheet. One way to determine the unit of analysis in a data set is to examine the cases in a spreadsheet. If we see that each row, that's a case, in our spreadsheet has an individual's name, then it's safe to conclude that the unit of analysis is the individual. We cannot draw conclusions about states using data with individual micro-level cases. We can only draw conclusions about individuals in our sample or population. If we note that each row in our spreadsheet has the name of a state, we know that we are working with a macro unit of analysis, and we cannot draw conclusions about individuals based on these data. With macro, just like microdata, we must make sure that we are consistent in the measures we use and our analyses are appropriate for that unit of analysis.